Okay, good afternoon class. So at this point we're looking at trigonometry, 2D and 3D problems. So today we're going to look at the 3D problems, okay? In grade 11 we have done 2D problems extensively, okay? However, the first part of this chapter we've dealt with the 2D problems where we had compound or double angles involved, okay? So now we're going to look at 3D problems, and 3D problems is on page. This example is on page. Example, exercise 3 is on page 121, is that correct?
Yes, sir.
And this example is on page what? 126. Okay, and this example is on page 125. Okay. Example 1 is on page 125. Alright, so let's look at what they tell us here. Please settle down if you don't mind, people. Okay. So here we are told that Unit 2, problems in 3 dimensions. 3-dimensional problems can be complex because you are working in 2 planes, vertical and horizontal. Now you must remember the vertical is the one that stands up straight. The sun is on the horizon. So your horizontal is at the bottom, while your vertical is what stands up straight. However, the horizontal plane will always stand perpendicular to the vertical plane. Okay, you guys understand? The horizontal and vertical is 90 degrees to each other. Right, so complex because you work in 2 planes, vertical and horizontal. Right angles do not always look like right angles. So if they tell you that this is you you got a triangle here on your horizontal plane, we will consider that to be your floor, and you got a wall built there. We know the wall will stand 90 degrees to the floor. Can you see that? Unless there's something wrong with your architect or your builder, it's not going to stand 90. Okay? But it's strongest, your walls and those things are strongest at the 90 degree angle. Okay? So it's normally 90 there. So as they're saying, it doesn't always look right, but it's a right angle. The diagrams below represents 2 typical 3-dimensional diagrams where A and AB is a vertical height, BCD on the same horizontal plane. Okay? The horizontal plane is shaded. It's normally shaded, or we look at the horizontal plane to what is on the ground, basically. Okay? And you see here that ABD, that is 90 degrees there, and ABC, that angle is also 90. You see that, people? And here as well, ABD, that angle is 90, ABC, that angle is also 90. You guys understand? Why? Because the horizontal is perpendicular to the vertical. Okay. And those are basically the 2 common used diagrams for this 2D problems. Okay. So let's carry on with our life. Let's look at an example. And this is example 1 on page 125. And this example is for exercise 3 on page 126. Okay. So here we are told that Sheila and Desmond, is there any Sheila here? No, she left, no? Yes, she left last year, okay. And that's why she got the A for maths, no? You must check if your names are in the textbooks. Okay. Sheila got the A for maths. Okay, nice. Sheila and Desmond stand some distance away from building AB. Okay. This diagram doesn't look so. Right, that looks a bit better. From AB. That has a height of 12 meters there. the foot of the building B, Sheila and the foot of the building B, Sheila and Desmond are in the same horizontal plane. So that point B, Sheila and Desmond is in the same horizontal plane. So that is on the ground basically to us. Okay. The same horizontal plane. The angle of elevation from D to the top of the building A is 40 degrees. Can you see it? D is 40 degrees. Okay. And from C to A is 45 degrees. You all see that? Then we are told that C, B, D is 55 degrees. Calculate the distance between Sheila and Desmond. So in other words, I'm working out then CD. Can you see that, people? Okay. Here this diagram is a bit too small now. So I don't need that anymore. I'll go a bit bigger. And there we go. We are going to need to calculate the length of CD. Can you all see that, people? But now there's many triangles. Okay? There are many triangles. But just to refresh our memory, if we got this angle and I want to calculate that rule, that length, which rule am I going to use? Not the sine rule. Well done. Cos rule, man. Why? Because we will have then the included angle, considering we need those sides. Can you see that, people? Just remember that. Yeah, the cos rule. So now, what are we shorting in pursuit of using the cos rule? I'm shorting BC, yes, and I'm shorting BD, which are the two included angles. Why am I not going to use the sine rule? Is because if I need a sine rule, then I need to have another angle, which I don't have. However, I can calculate sides here, which is BC. Also, if you didn't know that you had to use the cos rule, we have to examine the diagram and see what can actually be calculated. And you would have came to the fact that in triangle B, A, C, I can calculate BC. Can you see that? That is, remember, the sense 90 degrees to the horizontal. Can you see that, people? This triangle I've just drawn there now. Flat. Can you see? You all understand? So what can I fill in this triangle? I can fill in the 90, the 45 degrees, yes? And 12. Okay, I think I must put it a bit bigger now. So in triangle ABC. So it's going to be 90 at B, C, and A. That is 12, 45. So what can I work out, people? I can actually work out BC. And that's what I want. Not so. So let's go. So which trigonometric function you're going to use to calculate BC? 10. So we go. Tan of 45 degrees is equal to opposite 12 over BC. That's naturally over 1 across multiply. What's tan of 45? Work it out. What's tan of 45? 1. Okay. So in other words, 1 times BC is equal to 12. So this length is 12. You all agree with that? You all understand? Right. Now let's look in the other triangle. In triangle ABD. In triangle ABD. What can be calculated here? Let's draw the triangle. What can be filled in here? Remember that is B, D, and A. What can be filled in? 12 years for AB. 40 years at D. And 90 degrees. Why? Because again, that stands perpendicular to the horizontal. Make sense, people? It's easy, no? Alright. So what we're going to calculate here? BD. You could have calculated angle A in that triangle, but it's going to be futile, useless. No? Did I use the right word? Now, tomorrow I'll start teaching English. Never, no? Right. But, and I can calculate AD. But it's again useless. I don't need it. Okay? But what I need is actually BD. You all understand? So, which trigonometric function uses opposite and adjacent? Again, tan. So, tan of 40 degrees equals opposite, which is 12 over BD. There's a natural over 1 across multiply. So, BD tan 40 is equal to 12. So, BD is equal to 12 over tan 40. So, you say 12 over tan 40. 12 over tan 40 gives me 14,3. Is that correct? 14,3 meters, whatever. This here is 14,3. So do I have enough information now to calculate DB using the cos rule? The distance between Desmond and Sheila. Yes. I'm going to take this off here. That is to keep the diagram in focus. Okay? So we didn't use green. Alright? So now in triangle BCD. People, what you also notice is that I'm drawing the triangles next to the calculation so that the examiner knows what I'm seeing. Okay? So you guys see funny things. Not so? Yes. So I just draw it. Let's say you got C, D, B. What can I fill in, people? 55 at B is? What else can you fill in? 12 is? 14,3. And I can fill in 45, not so? No, don't make sense. No. That 45 is in a different triangle, Michael. Okay. So let's go. CD squared is equal to what? 12 squared plus 14,3 squared minus 2 times 12 times 14.3 cos of the included angle, which is 55. I know some of you again like drawing or writing. So you would write first CD squared is equal to BC squared plus BD squared minus 2 BC times BD cos of angle B. Not so? If you had written that first, no problem. No, for no extra marks, okay? And of course now this can be calculated. So let's go. 12 squared plus. Now 14.3 was my last calculation calculated, not so? So what do I press? Answer. Answer squared minus 2 times 12 times answer cos 55. That gives me 151,65. 151,65. So that is CD squared, 151,65. Therefore CD works out to be now square root of answer is 12.3. So they are 12,3 meters apart. Do you guys understand? Any confusion? Huh? Is it correct? Okay, we'll do another one. Can I move on? So writing? Okay, so finish up again.
I like ocean.
Okay. So let's look at example 2, and example 2 is on page 126. So this is also for exercise 3 on page 126. Okay. Oh yeah. Right. The figure shows a cube. What's a cube, people? So a cube is constructed of 6 squares, no? So we mean to say all the lengths are equal on the cube. Okay, the height, the length, the breadth, it's all the same. In this case, it's going to be 20 millimeters. Calculate the angle that the plane ABR is. Let's just highlight that. ABR. Oh yeah, R is. Okay? Calculate the angle that plane ABR is makes with plane ABCD. Okay, that's it. So in other words, they want you to calculate this angle here. Not so? You all agree with that? And let's call that theta for now. Okay. Right, so let's see what we can do. Alright. There's 2 parts of the question, so don't forget. Okay. So let's go. Hey. Okay, so people, if you look here, if I need to construct a triangle here, with that angle theta, I can only see one triangle, which is B, C, R, B. B, C, R, sorry. I said B twice. B, C, R, that triangle. You all agree? That's the only triangle that angle that they're referring to in is line. Okay. So if I draw that triangle, I can take this off here, so the diagram is now becoming overpopulated here. Here we got this. So that is C, R, B. What can I fill in? That is the angle I want to calculate. Okay. For now, I'll just call it theta. We can fill in the 90 as the 20 is RC, and also 20. You all agree? No? Why is RC 20? Because all these lengths on the cube is equal. Not so? So how am I going to calculate theta? By using Pythagoras. 10 or 10. So tan theta is equal to opposite over adjacent. So it's 20 over 20, which is 1. Arc tan of 1 is 45 degrees. So this angle is 45 degrees. Okay? You all understand, eh? I'm sorry that this work is so easy, man. Yes, isn't that the answer? Oh, yes, it is. Because it's an isosceles triangle anyway, so you didn't have to go that route. If you wanted to say it's 45, because that's an isosceles triangle. Okay.
Sir?
Yes?
How did you say it's 45 degrees because it's the diagonal?
Of a square. Give her a round of applause. I forgot about that.
Sir?
One day we're all going to be so sharp like you. Just not today. Right, yes. Next question, yes, Goliath? Go for it.
How
Yes.
do you know which angle to calculate?
Otherwise, which other angle are you going to do? Remember the question says, calculate the angle that the plane, this plane here, makes with that. Which other angle can you then calculate? Not O, there's no O, there's a A, the Q, no O. A D is? They all look like O's, no? O's, right. But you guys understand? No, you all understand? Alright, nice. Right. Now we are told, can I carry on? Now I'm told, settle down. Okay. Now I'm told, calculate the angle that the diagonal BS makes with plane ABCD. So calculate the angle that BS, where was BS? Yes, BS makes with plane ABCD. So it's this here at the bottom. So which angle are they referring to? Is B D. I think it's this angle here. Because the whole angle A B is. Yeah, this is your ground here.
Oh,
What don't you get?
ABC is the threshold, is the base of the square, and then you see that AC is going to a capital sign. You see it? So the calculate is the angle.
We may take this off here. I think you guys are shooting off fuse. Yes, the angle of it to do with the angle of elevation is.
And then the swap so through. Yeah, an angle. And then what we will calculate the angle.
You got it now? Okay, calculate the angle at diagonal base. So this is your diagonal, you have no problem with that. The diagonal BS makes with a plane. So the plane is what's on the ground. So what you do is, if this is your box, okay, your diagonal is going from this one point, this point here, to this point, the hidden point there. Can you see that, people? So that line going from that point to this hidden point here, they want you to calculate that angle it makes with a flat surface, which is the plane. So they want you to work out that angle. The angle that you're referring to here is where? I don't know where that is. That is in another plane. You're going to go in 4 dimensions and 6 dimensions. Okay, you got it now? Don't lose it, no? Because at the end you're not going to ask me again how do I get it. Okay. So, let's go. This is 1.2. I wrote by mistake earlier on A. I had to write 1.1. Okay, so which triangle am I going to work in? Triangle. In triangle is D. D belongs here, no? Is D, B. So what can I fill in here? Is DB. I can fill in the 90. Yes, what else can I fill? The angle that you want you to work out, let's call this beta for now. What can I fill in? Sorry? I can work out is D. Is D is 20. So in pursuit of calculating angle B or beta, I either need DS or I need SB. Which one of the two can I work out at this point? BD. Yes, why? Why BD? Sorry? We already have 2 sides. What type of shape is that? A square. Okay, let me just do it nicely for you. That is D, C, B, A. Can you see? That DB. That is 20. That is 20. What's the size of angle A? 90. So I'm going to calculate BD. Huh? What? Pythagoras. Yes. So it's going to be 20 root 2. Now say we didn't know that. Okay. So it's BD squared is equal to 20 squared. People, please settle down. Okay, you start talking in the background. The people's already confused. And are you talking? So they want to be part of the mother's meeting, no? Right. Pythagoras then. Can you see that, people? So that's going to give you 400 plus 400 is 800. So BD squared. So BD is equal to the square root of 800, which is 20 root 2. Okay. So that is 20 root. Do I have enough information to calculate that angle now? Yes. So which trigonometric function and am I going to use there? Opposite and adjacent is tan. So tan beta is equal to 20 over 20 root 2. Okay? So beta is equal to arctan of 20. Arctan of 20 over 20 root 2. Well, let's just put the root 2. 1 over root 2. Will give you 35, 26. 35,26 degrees. Okay. It's probably 7 marks per summer. 6 or 7. Okay, listen. That's for one sum for number 1.1 and 1.2. Together, yeah. Later on you get one that's one sum that's 7 marks. People, this section of work is 10 marks, 10 to 12 marks out of your paper 2. Sometimes it's 9, very seldom, but it's, or 8 also very seldom, but it's normally between 10 and 12 marks. Okay. There's one explanation that's going to take place tomorrow. Please come to school. Don't eat tomorrow yet. Okay. At this point, you should be able to, you guys will stay at home tomorrow because it's eat on Saturday. Yes?
So why is 3 times
20 root 2, isn't it?
No, but why?
So 800, because that's going to be 4. Remember that is going to be 20 squared is 400, no? Plus 400 is 800. No? That is BD squared. Now if we take the square root of that, it's going to be, now you ask yourself, okay, what's the largest perfect square that goes into 800? It's 400. So 400 times 2. What's the square root of 400? 20. And that is why the square root of 800 is 20 root 2. Do you understand? Okay, anyone else want to confuse us? No? So with that you should be able to do exercise 3 on page 126. Alright. You guys can start with it now. Everything is, what do you think? I'll stop the video at this point.